Alright, hello everyone. So this is a quick presentation for a project, actually two projects that I did, and I just wanted to explain them really quickly. The links to the code for these projects is in the description down below, and they're on GitHub. So basically, what I wanted to try to do was create a convolutional neural network to classify images of people into their respective genders. And, oops, so how would you do this? And I find this classification task very interesting because both male and female faces are made of the exact same things. You know, we both have eyes, we both have nose, we both have lips, we both have ears, etc. So if you were to manually try and describe to someone a rule set for classifying male and female faces, you'd probably have a very difficult time. You know, even if you did find certain attributes that are true often, like, hey, you know, if it has short hair, it's a guy. That's not always true. There are women with short hair, there are guys with long hair, etc. So this sort of classification task is very different from doing something like classifying an image of a coffee mug and a dog. You know, because those things also look different. They're different in terms of their components. And with faces, we're made up of the same types of pieces. So I was curious if a neural net could be trained and do well for this sort of task. And the way that I did this was I retrained the final layer of TensorFlow's Inception module. And basically, Inception is a giant convolutional neural network trained for the ImageNet competition, which is a classification competition where there's, I think, 1,000 classes. I love getting this message. It's my favorite thing. Yeah, this message is shit, and I always get it whenever I use OBS for some reason. So we'll close it, and hopefully it doesn't come back. But yeah, so Inception is a big-ass neural net that has already just been trained and was used for the ImageNet competition, and it's really good. And so what we're going to do is we're going to retrain the last layer, and this is called transfer learning, where you take basically a pre-made model and you retrain part of it for your own purpose. And basically, the reason why this works is originally when you train a neural net for the first time, it takes tons of data. And so a neat little plus of transfer learning is retraining the last layer, because you're only retraining one layer. It requires much less data than training a whole network. So if you have a small amount of data for an image recognition task, transfer learning could be a great option for you. And also, we get to build off of this fantastic neural net, which Google came up with. Even deeper why this works is why we're able to just retrain part of it, and god dang it. Alright, maybe I should read this before I delete it. Detected computers' performance is slow. This could be because there are not enough resources. The arrow color scheme. So it's telling me that my background is too complicated when I run OBS. To improve performance, try changing the color scheme to Windows 7 Basic, and the change will take effect. Change the color scheme to Windows 7 Basic. Keep current color scheme, but ask me again if my computer. I don't want you to ask me again. So here's my mistake. Alright, there. Click that. What was it getting at? Yeah, and so the reason why we're able to reuse a pre-trained neural network is that a lot of the stuff that these convolutional neural networks learn is universalizable and can be applied to any task. So the ImageNet neural net will have learned things like edge detection, which will be learned if you were to create a neural network from scratch for a different purpose. So a bunch of the stuff under the hood, the very fundamentals of recognizing images, can be applied to anything. And so we really only need to retrain this last layer. And finally, where did we get the data for this task? Well, you can try and find your own data source. I used a Chrome plugin called FatCun Batch Download Image Downloader. Yeah, I ended up just going on a site where you can search, you know, like Google Images or wherever you prefer, and I made my data set that way. And it was, I think, a couple hundred images for each class, and that's all I used. Alright, so what were my results? I achieved 86.5% accuracy, and, you know, I'd be over the moon if I hit in the mid-90s. But that's pretty good. That's better than I thought. It's at least to me that's very significant. This is a very hard classification task, and I'm happy with those results. And so I apply this to the MNIST dataset, and I achieve 95.3% accuracy. And I tried to get it higher, but it wasn't happening. And this leads me to some conclusions. Just for frame of reference, the MNIST dataset, when I built my own neural network, I achieved over 98%, and other people achieved 99% without too much difficulty. So 95, even though that sounds great, is really a little bit lacking by comparison. So what were my conclusions from this projects plural technically? For starters, CNNs can indeed be used for these difficult classification problems. Transfer learning can be a great option in some situations, especially when you're short on data, because you're only retraining that last layer and they require less data. And finally, transfer learning can give you good results, as we saw with the facial recognition task, or classification task, but it probably won't give you the best results. And I learned that when I tried to do classification with the MNIST dataset. Because, again, 95% seems pretty good, but that actually is, in terms of the dataset that we're trying to classify, not a superb result. So it's definitely worth exploring, but all things considered, the best option, maybe not the most convenient one, but the best one seems to be retraining your own network from the ground up. But anyway, I had a lot of fun with these projects. The code for the GitHub repos for each one is down below. And yeah, hope you enjoyed. Bye.